When we're trying to determine if a compound is ionic or molecular, we just have to remember that molecular means it's going to be composed of all nonmetals. They're going to be sharing electrons. And then if it's ionic, that means it's going to be made up of metal and nonmetal, or it could be made up of the polyatomic ion ammonium and nonmetals. Because if it has that, that's an ion. It's a polyatomic ion, which means it will be ionic. So N2O, nitrogen, oxygen, both nonmetals, no polyatomics present, it's molecular. Barium fluoride has a metal, barium, and a nonmetal, fluorine, so that's going to make it ionic. And then NH4 is our ammonium ion, NO3 is our nitrate ion, so since they're both polyatomic ions, we have an ionic compound. If just one of them was an ionic compound, it would, or a polyatomic ion, then it'd be an ionic compound. Okay, if we want the common ion formed, we just have to look at our periodic table, see which column it's in. Sodium's in group 1A, the alkali metals, so it's Na+. Zinc is in the transition metal group, which is mostly question marks, but it's one of the ones that we wrote a charge on. It will always take on a charge of 2+. Bromine is a halogen. It's in the next to last group, group 17, has a -1 charge. Barium's an alkaline earth metal in the second group, group 2, so it has a charge of 2+. Aluminum's in the boron family, and it will have a charge of 3+. And then sulfur is a chalcogen in the oxygen family, has a charge of -2. Okay, when we're going to name compounds, it's important to identify first whether it's going to be ionic or molecular. That's going to help us figure out how we're going to name it. The molecular ones are going to have our Greek prefixes, so as we look through, we identify that this one and this one are molecular. So when we name those, we just look and see 2 is di, so it's disulfur. And we only change the ending on this last one, so it's going to be trioxide instead of oxygen. Okay, for this one, we only have 1 phosphorus. We do not use mono except for the second element in the compound. And then 5 is going to be penta. So it's pentafluorine, which gets changed to pentafluoride. Okay, the remaining 3 are going to be ionic because they're made up of metal and nonmetal. And we're going to first write down our metal. So Cu is copper. And we'll just go and fill in all the metals. Na is sodium. And Fe is iron. Now we can determine whether or not we need a Roman numeral after the metal by looking it up on the periodic table and seeing if we know the charge. So Cu, copper, when we look it up, it's a transition metal. We did not write a charge on it, so we are going to have to put a Roman numeral after it. When we look up sodium, sodium's in group 1, it's +1, it's good, no Roman numeral. For iron, Fe, it's also a transition metal with a question mark for the charge, so that means we will need a Roman numeral. The last part of our compound will just be the name, changing the ending to IDE unless it's polyatomic. Polyatomic just keeps its name. So Br is bromine, so it becomes bromide. Cr2O7, that's one of our polyatomic ions, and we know that because there's more than one capital letter there, and that's going to be dichromate. And you have to kind of watch out for that one because even though it starts with a di and you think it might be something to do with molecular, that is part of the name of that polyatomic ion. It has nothing to do with molecular. And then finally we have SO3, that's going to be sulfite, another polyatomic. So then to find those Roman numeral charges that we kind of skipped over, we have to look at the charge of what is attached to that metal. And so whenever we look at bromine, one bromine would have a charge of -1. And since we have 2 of them, that means this entire half to the right has a charge of -2, which means that everything to the left will have to have a charge of +2. There's only 1 copper, so its charge will be 2. For iron, we're going to look at sulfite. Sulfite has a charge of -2, and we have 3 of them, so we have a total charge of -6 on the right. So on the left here, we have to have a charge of +6 overall. We have 2 irons, so each iron will have to have a charge of a +3. 1, 2, 3. Okay. For the last part here, writing formulas, if it is molecular, we are going to use these prefixes to determine how many of our element we'll have. We do not look at charges for molecular. So nitrogen di is 2, oxygen tri is 3. Simple as that. Xenon has no prefix, so it's just Xe. Hexa is 6, so we have 6 chlorines attached. For the remaining ones, these are all going to be ionic, metal, and nonmetal, which means we will have to look at the individual charges to see how they're going to come together. So we look up calcium, it's Ca2+, and we look up cyanide, it's a polyatomic ion with a charge of -1, Cn-. So that means we're going to have twice as many cyanides pairing up with our calcium to get those charges to balance, to add up to equal 0. So we're going to have Ca, and then Cn, if we just put a 2 out front, that would only put the 2 on the end. So we have to put the cyanide in parentheses when there's more than one, and then put the 2 out front. Iron, we have a 3 after in Roman numerals. That means our symbol, or our ion, will be Fe3+, and then chlorine is Cl-. So to balance our charges, we'll need 3 chlorines paired up with our 1 iron. Finally, we have tin, Sn, with a charge of 4+, and then phosphate's a polyatomic ion, PO4 3-. So when you look at 4 and 3, our least common denominator would be 12. We have to make them both be 12. So 4 has to be multiplied by 3 to get 12. And then our phosphate goes in parentheses because we're going to need to multiply -3 by 4 to get a -12. So they can cancel out. Remember, you can also look at these charges and they can just kind of swap places. So that means that the 3 will come over here for the tin, and then the 4 will come over here and be on the phosphate.